All right, let's take this to the next level. How can we navigate a maze? Basically, can we go from start S to T? Can we figure out the shortest route? And how fast can we compute this? So if we were given a maze, and we want to find out if we can go from point A to point B, what would y'all do? If you were just given this on paper.
I always start at the end.
You start at the end and go back? All right, but you pick a spot, and then you try to go from there. So you just start following a path until you realize, oh, I can't go that way, and then you try and find another path? All right. That's actually the recursive method of doing it. There's different ways of doing it.
Unfortunately, I don't see a way in these games.
Yeah, I don't see a way in or out.
Well, you have to use your imagination. We'll say the top left is the start and the bottom right is the end.
What would be really funny is if there was no way to get to the bottom right.
That would be good. Well, I mean, that's the question. Can we go from S to T? That's probably the first thing we should ask. So let's code this up. New Java class, maze. Yep. All right. Public static void of main. String args. All right, let's try and make this maze at least somewhat easy to recognize. We'll make it a character array. Private char and maze equals. We'll have O be open and W be wall, S be the start, and E be the end. So if we want it for finish, sure. For you, Tyler. So let me go ahead. See, that's two of them right there. 3, 4, 5, 6, 7, 8, 9, 10. A comma, semicolon, and that way we can copy. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we'll put the finish line over there and the start point up here. Okay, start, finish. All right. Actually, let's not have a starting point. Let's just have a finish point. Nothing else. So we could put some walls in here. Maybe we can make that a wall, that a wall, that a wall, that a wall, that a wall.
You have to do it with the pattern. Start at 1, and every time you add an extra one, then you jump down.
Yeah, so maybe we'll put another wall right here. I'll put a wall, pull a wall over here, wall right there. Put a wall up here. Let's see what we're doing here. Let's go ahead and create a little more walls. All right. So the question is, in this maze, can you go from a certain position to another? So let's go and make a little, basically we're asking, let me go ahead and put my comment up here. O is open, W is wall, F is finish.
Is it really?
Sure, isn't that what you wanted?
It's finish?
What would you like it to be? Fin?
Finland?
Fin what?
It's from Finland?
Finland? Oh, it's Fin. Oh. Good job. Nice. So the question we could have is public boolean can, or let's see, path to finish exists, int start x, int start y. So basically, given a starting point, can we get to F?
You're going to want to add a T to the start. Y.
Instead of the star Y?
Sorry.
And I'll just, instead of start, let's just make it X and Y, right? path to finish exists from X and Y. So how can we do this? We can do it using, oh yeah,
Yay.
all right. So if we were going to do this recursively, what's the first thing we should take care of?
Big case.
The base case. What are the base case or base cases here?
That you're already finished.
Yeah, I'm at the finish. Okay, great. So if m maze sub x sub y equals the finish, we return true because we found it. All right. Okay. What's another base case?
There's no way to get out. There is no.
Okay, sure. So that's not necessarily the base case, but we'll say no other options, return false. All right. So if we're out of position and we want to find out if we can go get to the finish line, what do we need to do?
Check the
Next, which way do we check?
Rows. Right?
Well, we're out of position. Which way can we go?
Oh.
Up, down, left, right?
Yeah.
Okay. So we could do path to finish exists. So we could do X, maybe we'll go down the Y path. Right? So if we're starting top left, Y would be going, see, X is the row, Y is the column. So this would be down. Maybe we want to try going up. Up. Oh wait, I did that backwards. I always do this backwards. That's down. Whew.
How is that done?
Because if you're,
Oh, and row X.
yeah, row X down, you would, oh, I'm sorry. Row X down would be actually, yeah, decrementing by 1. I'm sorry, down would be incrementing by 1. I said it backwards. Up is decrementing by 1. One day I'll get this all straight. So we want to go down by adding 1, and we want to go up by subtracting 1. All right. And then if we want to go left, we do path to finish exists of x, comma, if we want to go left, it would be y minus 1. If we want to go right, would be y plus 1. Okay.
Is that backwards?
So left, so we're right here. If you're subtracting y, you would go over here. So that's correct. And if you're going increasing right, it'd be to the right. So here you go. Your question is up, down, left, right. Can we? So those are the 4 ways we can go. Now, what are some other base cases here? One that's just flip, keep trying to go left and right, or what could be some other problems with this recursive function? Well, if we started at 0, 0, what would be x minus 1 be? Negative 1. And is that something that's legal? All right, so we really should say if point is not valid, x comma y, return false. And then we'll create a point is not valid. Private Boolean point is not valid, int x and y. And that would be the case that, so if x is less than 0, or y is less than 0, or x is greater than or equal to m maze dot length, or y is greater than or equal to m maze sub 0 dot length. Basically, if it's out of bounds of anything, then just return false. Otherwise, return true. Okay? So the point's not valid. So if it's not valid, return false. If we're at the finish, return true. What else do we need to check here? Or what else do we need to think of? Because we're calling ourselves and we go up to 1 to the x and then we come back.
You gotta establish if it's a wall or not.
That's right. We have to establish if it's a wall or not. Would that be a base case? If m maze sub x sub y.
No, because you wouldn't need the end if you hit a wall.
Yeah, you hit a wall, so we'd return false. You know, you can't go this way, right? That's false. You've hit a wall. We're done. What else? So you can't go into a wall. You're in the finish line. You're done.
Where do you start?
Wherever you're given. So let's go up and give it a start point. System.out.println path to finish exists of 0, 0. And just realized we need to make this static. Ooh.
Didn't like that.
Yeah, we have a lot of static things going on. And then let's make this guy static as well. It's only one maze. Alright. So you got your starting point 0, 0. Okay. If it's not valid, return false. If you're on a wall, return false. If you're at the finish line, return true. Then you go down, up, left, right. What else do we need to do here? You know what? Let's put a little statement right here. System.out.println. We'll do x plus comma y.
But are you actually setting the x and y values after you move? You know what I
Well,
mean? Checking.
whenever I move, it replaces x and y with the new values,
I didn't
right?
know if that guy was just like looking, hey, this guy.
Well, let's run this real quick and see what it does. I think that might shed some light on what's going on. Ooh, false. That was fast. Wow, it even print something out. So if point is not valid, is not valid. So we want to, if point is not valid, so we actually want this to be true. And this guy to be false. Did that backwards. Let's try that again. Whoa!
Oh,
What's going on here?
what are we thinking?
Bouncing between two values.
It's bouncing between 1 or 2 values. How can we stop that? So basically it's going all the way down, and then going back up, then back down, then back up, then back down, then back up, then back down, then back up, then back down. How can we stop that?
Take out one of them. Take out the
Take out one of them?
It doesn't help you, but it gets rid of that problem.
No, we still want to be able to go down, up, down, left, right, right? Correct? Well, if we're at a point, if it's not valid, if it's a wall, we're finished, we're done. But if we've already visited the point, we don't need to revisit it again, right? So we need to come up with a way of representing visitation. So we'll just say m maze sub x sub y equals v for visited. And that way, if we're up here and the maze is a wall or m maze we've visited before, we know to stop, right?
What if you have to backtrack?
Yeah.
Well, that's fine because we're recursing down. It's recursive backtracking. That was an excellent word, mate. You said it before I did. Because you're recursing down. Remember, you're building on a stack of everywhere you've been, and then when you hit the back, you kind of pop up until you find somewhere else, another position to go.
Oh.
So you're doing what you do on paper. You go down a path, oh, that didn't work, try another path. You know, if I visited a point, don't keep trying. Okay. Well, let's see if it stops this time. Oh, it stopped. Of course, it returned false. Well, if path to finish exists between these two, we actually don't cut out correctly is our problem here. We should return true. If path to finish exists here, we should return true. You know, I'm not actually checking it, and I need to add those checks in. And yeah, we'll just keep up with the pattern so it's a little clear. So if you do find a path along one of these sides, go ahead and return true. And we're done, right? You don't need to go check another path. We found a path. We're done. Let's go and run that. Oh, true now. So it did find a path. Does that make sense? Is there a possible path here? Yeah, it looks like there is. Is there any way we could plug this up real fast?
Yeah, right there, second column.
Yeah, put a wall here and a wall here, right? Yeah.
You don't need to worry about that one because there's a wall.
No, because once you go across here, you can come up here.
Get the top of that column.
Oh, this one? Yeah, that would do it.
The one you're in right now.
The very top. No, because you go this way, you stop here, you go here. The path is going down through this little canal up here. So if I put a wall actually right here, that should stop it. False. It was actually kind of cool if I were to come up with a print maze function for you. I do private static void print maze. Ooh, that's the other type of maze. For int I equals 0, I is less than int maze.length I plus plus. For int j equals 0, looks like I misspelled length. M in maze sub I dot length j plus plus. Go up here. There it is. Reduce system dot out dot print in maze sub I sub j, and then down here we do a little new line. If I were to print the maze, it would actually show you what paths it tried. Yeah, watch this.
Whoa.
So the V's are where it tried. Let's see if I can make this a little bit bigger. Come on, mouse, you got this. So you can tell it tried going all the way over here. So all the V's is where it visited, but it wasn't able to punch through to those where all the O's are. If I were to go back up to my maze, maybe open it up right here, and then I was able to run it. True. And it actually shows you where it visited. It didn't even go over here. It just visited and then eventually came to the finish line down here. So obviously maze traversal is probably a little more complicated than what y'all have been coding so far, but hopefully you can see that defining it recursively is actually not that bad. Because you're basically saying, is this a valid point? Let me do all my checks. Okay, I am. Let's go ahead and try this point and try going up, down, left, right. All right. Any questions about this? No? All right, well next, is your lab due today or on Thursday? Thursday, okay, good. So on Thursday we'll talk about the stack as a data type, and then I'll give you another lab 9.
What lab is due today?
What?
Lab's due today.
Lab's due date? Okay, that's fine. Good, then you'll have some breathing room.
Lab 7's due today or lab 8?
Lab 7's already due. Lab 8. All right. Well, that's all for today. I should be caught up on all my grading. That includes your requirements and your design. I did not regrade labs 1 through 5, but I did grade labs 6, 7, and your design. And I think one of the groups I regraded the requirements. So if you have any questions about that, please get in contact with me. And also, don't forget to sign up for the interview workshop. Any other questions? All right, have a good day.